Myostatin is a protein the body makes on purpose, and its job is to keep muscle from growing any larger than it already is. It isn't a malfunction, and it isn't a deficiency. It's a governor, present in nearly every vertebrate that's ever been examined for it, and it's been doing this quiet work in human bodies for as long as there have been human bodies. Most people who spend years training against it never learn that it has a name. It was identified in 1997. Two researchers at Johns Hopkins, Sejin Lee and Alexandra McFerrin, were studying a family of signaling proteins, and they disabled the gene responsible for one of them in a line of mice. The animals that resulted were roughly twice as muscular as ordinary mice. Their shoulders and hindquarters were thick with it. They'd been fed nothing special and had done nothing to earn the size. A single gene had been switched off, and the body had simply stopped holding itself back. The protein that gene encoded was named myostatin, from the Greek words for muscle and for stopping. The same pattern shows up out in the world, on farms across Belgium. The Belgian Blue is a breed of cattle whose shoulders and haunches look inflated, the muscle visibly grooved and stacked beneath the hide. For a long time, the breeder selected for that look without knowing what caused it. The cause turned out to be a natural mutation in the myostatin gene, a small deletion that produces a protein that no longer works. The breed had been accumulating that mutation across generations. Nobody engineered it. The breed had worn out on its own, and the farmers had spent decades quietly selecting for the wear. There's a price for that wear, and the cattle pay it. Belgian Blue calves are often too large and too muscular to be born the normal way, and a great many of them are delivered by cesarean section, sometimes as a matter of routine on the farms that raise them. The same trait the breeders prized made the animals worse at the most basic thing an animal does, which is reproduce without help. That detail tends to get left out of the supplement advertisements. In 2004, a team of German doctors, led by Markus Schwilke, published an account of a child born with a comparable condition. The boy had visibly defined muscles from his first days, in a way that infants' muscles are not. By the time he was a few years old, he could hold a small weight out in each hand with his arms extended straight to the sides. His mother, a former competitive sprinter, carried one altered copy of the gene. The boy had inherited two. As far as the published account recorded, he was healthy, though the doctors were careful to note they couldn't say what a lifetime with almost no myostatin would do to a heart, which is also a muscle. What myostatin actually does, mechanically, is unglamorous. It belongs to a family of signaling proteins called the transforming growth factor beta superfamily, and it attaches to a receptor on the surface of muscle cells, setting off a chain of events inside them that suppresses the machinery of growth. The cells that repair and rebuild muscle, the satellite cells, are told to hold back. The message is restraint, and it's sent continuously. Remove the message, and the cells go on to do what they were always capable of doing. The reasonable question is why the body would build a system specifically to limit its own strength. The likely answer is cost. Muscle is expensive tissue. It burns energy around the clock, even at rest, and for most of human history, energy was the scarcest thing a body had to manage. An animal that grew unlimited muscle would be an animal that starved a little faster every time food ran short. So the body kept a brake on, and the brake was an advantage, right up until the moment a person walked into a gym and decided the brake was the enemy. The volume of that braking signal isn't the same everywhere in the body. Myostatin shows up at different levels in different muscles and different fiber types. For the person training in an ordinary gym, that unevenness is most of the problem, though they almost never know it has a name or a cause. There's a common belief, and it's probably the belief that brought you to this video, that certain muscles refuse to grow because they reject the food being eaten to grow them. The pictures of a man eating in a surplus, taking in more energy than he burns, watching that surplus build his chest and his arms while his calves stay exactly as they were, as if the calves had inspected the incoming calories and turned them away at the door. It's an intuitive story. It's also not how any part of this works. Energy balance isn't local. The body doesn't deliver a particular meal to a particular muscle and let that muscle accept it or decline it. A surplus is a condition of the entire organism, more coming in than going out, and it's available everywhere at once. What changes from one muscle to the next isn't whether the muscle receives the raw material. It's whether the muscle is permitted to use that material to grow. Myostatin governs the permission, not the supply. In the muscles where it speaks loudest, the surplus still arrives, finds no permission waiting for it, and goes where unused surplus tends to go, which is to fat. So the trap, if it deserves the word at all, is quieter than the story makes it sound. The food gets in, the brake holds, and the trainee, watching the scale climb while the stubborn muscle stays flat, decides something about him specifically is broken, when what's actually happening is that he's trying to overfeed a governor that has never once responded to being fed. There's something almost comic in the effort. Gallon of milk after gallon of milk poured against a protein that doesn't drink. This is where most bulks fall apart. My bulking program puts that surplus into muscle instead of your gut, with the full plan linked below. Start it before your next bulk turns into a 4-month cut. There is one lever that moves the signal, and it isn't a supplement. Hard resistance training itself lowers myostatin expression, at least for a while after the work is done, which is part of why training is the thing that grows muscle and eating, on its own, is not. The effect is modest, and it fades, and nobody has trained their way into a Belgian Blue. But the trained body does carry a slightly looser break than the untrained one, and it earns that loosening one session at a time, not one meal at a time. The calves are the muscle this happens to most visibly, and myostatin is only one reason among several. The calf is under load during nearly every waking hour a person spends on their feet. It's already conditioned, already used to work, and the solace beneath the more visible gastrocnemius is built largely from slow, fatigue-resistant fibers that were never much inclined towards size in the first place. The shape of the muscle, where its belly sits and how far the tendon runs beneath it, is fixed by genetics and visible from birth. Hanging all of that on myostatin alone would flatten something more complicated. But myostatin is in the mixture, and in some people, it's in the mixture heavily. Wherever there's a governor, a market appears to remove it, and that market arrived fast. Supplements sold as myostatin inhibitors have circulated for years, built on extracts of fertilized chicken egg yolk or on epicatechin, a compound found in dark chocolate and green tea. The marketing leans on the mouse. The suggestion is that a capsule might do to a grown man what a deleted gene did to a Belgian Blue. The evidence that any of these meaningfully lowers functional myostatin in a trained human being and produces muscle that man would actually notice in the mirror is thin to the point of absence. A molecule from chocolate is not a deletion in the genome. The body does make its own myostatin blocker, and it's better at the job than anything sold in a tub. It's a protein called follistatin, and when Sensogen Lee's lab pushed mice to produce extra amounts of it, those mice grew even larger than the ones missing myostatin entirely. That finding is what turned follistatin into a target for gene therapy, with researchers delivering extra copies of the gene to animals, and eventually to small groups of patients with muscle-wasting diseases, to see whether the body's own off switch could be turned up on purpose. The work is real, it's slow, and it lives in laboratories and clinical trials, not on the shelf behind the counter at a supplement store. The serious pharmaceutical effort was never aimed at bodybuilders. Myostatin tends to rise as people age, and that rise tracks with the muscle loss of old age. So drugs built to block myostatin or its receptor were tested as treatments for muscular dystrophy, for the wasting that comes with cancer, and for ordinary age-related decline. Several of them did enlarge muscle in the patients who took them. The complication, which repeated itself across trial after trial, was that the larger muscle wasn't reliably stronger. The size came, the function didn't always follow it. The governor, it turned out, had been governing more than bulk. The same mutation runs through a particular line of racing dogs. Among whippets, there are individuals carrying 2 faulty copies of the myostatin gene, heavily built animals known in the breeding world as bully whippets, and they're generally too thick to win. A single faulty copy tells a different story. Those dogs come out slightly more muscular than usual, and measurably faster on the track. Partly released, the brake helped. Fully released, it became its own kind of weight to carry, the same way it did for the cattle that can't be born without a surgeon. None of this changes much for the person standing in front of a mirror, wondering why one muscle answered and another never did. The answer is that the second muscle was handed a stricter set of instructions before that person had any say in it, and food doesn't reach past instructions. The surplus always arrived. The muscle had been told, long before the first meal of the campaign, to stay the size it already was. Thanks for watching, and I'll see you in the next video.